Hello and welcome to a new episode of Mostly Engineering and another part in our Enigma build series. And today we are going to do the spring-loaded pins. And if you look on the internet, you will find that you can buy a lot of these pins ready-made for relatively low money. And here we are. Here we have the spring-loaded pins. So that was relatively easy and a very short episode for today. Unfortunately, it's not that easy actually, because yes, you can find a lot of these pins on the internet and in various amounts of different sizes and shapes and forms. And trust me, I looked through hundreds of data sheets, but actually I couldn't find, for the love of God, one that would actually fit. These pins here, they have the right diameter, they have the right amount of travel, but they're overall too long to fit inside the rotor. And this is always a problem. One measurement is always off. So we still have to manufacture the pins ourselves. Nevertheless, we are going to use these pins because they actually already have the right profile on the side. So all we have to do is cut them to size and then manufacture a little disc that goes over here. We solder the two pieces together and we have our spring-loaded pin that looks a little bit like this over here. Should be relatively simple, so let's go over to the lathe and start with the discs. So welcome to the lathe and let's cut our disc. What I already did is put the material in and then plane the surface and already set our 0 point. And this time it's a little bit more complicated of a setup than the other pins, because this time we will have a tool change in between. But on the other side, this is the only setup we need, and we only need 26 of these pins. So overall, I think not so much of a deal. So as I said, I already planed it. Now we have to drill in the hole and cut a little trough so that our solder can flow into it and bind both parts together. And luckily for us, our spot drill has exactly the right profile. So we need a 2mm hole and our tip is 2mm in diameter, and then it gets a little bit wider so that we can create our trough. In the end, we want the hole like for a countersink screw, so that you have a picture. And you see, this is more or less exactly the profile we need. So let's So that's that done. Very nice. And now it's time for our tool change. Cutoff blade would be the best, but unfortunately I don't have one, so we have to use this cutoff tool, which has a lot larger surface, but we have to do what we have to do now. So let's set our tool. So I drive it next to our part, and now we have to set the distance. I know our tool is 3.1 millimeters wide, and I want to cut 1.4 millimeters. So together 4.5, and we take some gauge blocks, put them in here, and do the same on the other side. Unfortunately, in my sets, the 4.5 gauge block is missing, but no problem. That just means we have to puzzle on both sides this time. So set our stop. And now we just have to cut our part off. Now, because we have a large surface here, we will put a lot of stress on the machine. So first we have to go very slowly, and a little bit of cutting fluid will help the process. And a little piece of wood, so that when the part breaks off, it doesn't fly away. And our part is off, much earlier than I thought. And we see there's still a lot of material on the back, so that's not really good, because actually that's really hard to get rid of. It's too small to put in the machine, and sanding off will take quite a while, so that's probably not the way to go. I think we will have to cut these parts on the CNC. So let's try this, and maybe that works better. So, and here we have our CNC disc. In the end, it worked nicely, but you can see we have lots of spares around here because I had to do it 3 times. So the first time around, yeah, that was just bad luck because we tripped a little fuse in our workshop, and as a result the machine lost its 0 point and I couldn't find it precisely again, and you see the parts weren't round anymore, so not good. Second time around, I was just simply too precious with the material. I put the 0 point very close to the edge to don't waste any of my brass sheet, but in the end, the result was that the remaining edge was too thin to withstand the forces of the cutter, and so the machine threw the parts out before they were completely cut. And this is also a very dangerous situation for your milling bit because if this stands in somehow crooked, it's very easy to break the milling bit off. That luckily didn't happen. So 3 times is a charm, so did it a 3rd time and then it worked fine. So in the end we have enough parts, we have enough spares, even so they may need a little bit more cleanup. It's actually really fiddly to just peel off the remaining double-sided tape and then send off the burrs from the cut. But yeah, much easier than on the Lathe setup. In the end, the final cleanup we will do after the parts are soldered together, because then it will be much easier to hold on to these tiny parts. So let's solder them together and then do the final cleanup. So, and here we have the setup to cut our pins to length. Very simple. A block of MDF with a hole in it, and then in the right distance above it an abrasive disc. So all we have to do now is put the pin in, push it down, and then just cut it off. So let's do this. And so we have our pin in the right length, and let's do the rest of them. So let's put the 2 pieces together. We have our soldering iron here, this time with the fine tip. That's not my favorite because it takes a lot of time to transfer the heat, but considering the scale, that's our only option. And then we have our piece of wood. Now the hole in here is exactly 5.8 millimeters deep, so that we can just simply push our pin in here, then take the part and push it over. And now the parts are correctly aligned with each other. If we need to, we have a round file to widen the hole. And then we can just simply put them together. A little bit of flux on the part so that our solder can flow a little bit better. And then we take our soldering iron, push the disc down, and then solder together, and we are done. Very nice. And here we have our finished part. Looks really nice. Still needs a little bit of final cleanup, but we will do this later. So we soldered all the pins together, but as you see here, there's still a little bit of cleanup necessary. So here we still have a little bit of a burr from the CNC cutting, or in other examples we sometimes got a little bit of solder on the side where it's in the way. So final cleanup is necessary, but this should be really easy and straightforward. So I put the part in our lathe so it's hold on securely, and then just switch it on and send everything off we don't need. Quick and easy, and a little bit of a polish for good measure. And there we have it, a finished pin ready to go into our machine. So, and we finished our pins. Took quite a while, nearly 2 weeks to be honest, but this is more due to the fact that at the moment I'm working full-time. Starting January, February, it will be even a little bit more than full-time. So time for the project is extremely limited at the moment. So half an hour a day, maybe even less, mostly even less. So even such relatively simple parts will take quite a while. But luckily, the pins are finished now, and that also means that more or less all parts are finished. There are only two little parts left to manufacture in order to finish the clamp assembly. But then we have everything we need to do the wiring and final assembly of the rotor. So stay tuned for this. Like, subscribe, do the usual YouTube stuff. And meanwhile, I hope you enjoyed the video. And if you have questions, comments, let me know down below. And I try to answer them as quickly and correctly as possible. And all that's left to say now is thanks for watching and see you at the next time. Bye bye.